create a circuit that has both current sources and voltage sources in it. And I think when it has current and voltage sources in it, that's really what causes some of you trouble. So let's say I've got this circuit here. And let's make all the resistor values 2 ohms. We've got 3 amps, 5 volts, 10 volts, and 5 amps. And I'd like to discuss this problem from a nodal analysis and a loop analysis perspective. From a nodal analysis perspective, so to start, we'll do nodal analysis. Those arrows on the board were Jervell was setting up the camera so we could film today's lecture, so that we have one student who's sick, might be able to access it later. If any of you want to watch this stuff again, you'd be welcome to do that. I'm supposed to stay within the arrows. I think I'm going to have to go outside the arrows a little bit.
It's okay. I can move it.
So, from a nodal analysis perspective, would I rather have all current sources or all voltage sources? What would be easier for you, do you think, if I'm going to do only a nodal analysis?
Current.
Current, I agree. Because the idea of nodal analysis is I say all the currents coming into a node add up to 0. So the current sources are easier to work with than voltage sources. For example, let's consider node A over here. Nodal analysis for node A would say that plus 5 amps going in. And if I call this voltage node B, node C, node D, so 5 amps going in plus B minus A over 2 plus C minus A over 2 equals 0. So for node A, the situation was fairly straightforward because that was a current source. Right.
Aren't B and C the same node?
Thank you. I'm on film, right? And I've got the same node mentioned twice. So B and C are the same node. I can make them not the same node. Put a 2 ohm resistor there. Now they are different nodes.
Don't you have to have a reference point somewhere?
Yes. So let's pick our reference to be down there.
The 1 by D is 2.2.
No, it's just 2.
Oh, okay.
So 1 by
It's a ohm.
that's an ohm.
Sorry.
We need one more node.
Right there. So if we call that node E, now is node E a known or an unknown voltage?
It's known.
No, what is it? Compared to the reference? 10.
10.
Yeah.
10 ohm.
So E is 10 volts compared to the reference. Yeah.
Can you start from A and go up? Be like A minus B and then A minus C?
Yes. In fact, I think there's several others. Gardo likes to write the currents out of a node, add up to 0.
You can do that as long as you keep safe.
As long as, well, I even would get away with it if I did all the currents out of A add up to 0. All the currents into C add up to 0. All the currents into D add up. I'd be okay as long as I'm consistent within the same node. Because I think you'd all agree that all the currents going into a node have to add up to 0. You'd also agree all the currents going out of the node add up to 0. So as long as I'm consistent within that node, I'd be okay.
Do you need E labeled? Could that whole part just be 10 minus C over 2?
Yeah, I don't really necessarily have to have E
Okay.
labeled as long as I know it's 10, but I'm actually glad we labeled it.
Okay.
It's good to make it clear. E is not a separate unknown, and I'm not going to write E as an unknown anywhere in my equations. Okay, so what I'm trying to illustrate here, though, in nodal analysis, is that current sources are easier to handle than voltage sources. So at node A, I only had to deal with this current source, so node A wasn't too bad. I'll have more trouble working with node B. Oh, font, did I make another mistake?
Between 3 amps and 2 ohms and 2 ohms. Roger,
C
point
and
out.
D.
Alright, let's look at node B. Node B is the trickier one, at least initially. So with the nodal analysis at node B, I'm going to have a current going in, and a current going in. The problem is the current's coming in through a voltage source. And that's where you can get into trouble with the nodal analysis. So the way to handle that would be A minus B over 2 plus C minus B over 2 plus, I can't do 5 volts. Like what you actually can't do is write, well, I don't have a current, so I'll just put in a voltage instead. That's the biggest
Label
no-no.
current.
So, what was that, Isaac?
Label that IX.
So let's give that current some name. Call it IX. And then just stick that into your equation. So for the homework problem, that last one, it had both current and voltage sources in it. So even though you might have been able to get away in some nodes with a process that made sense to you, I think when a lot of you were getting stuck on that homework problem, you were getting stuck in nodal analysis, you were getting stuck with a voltage source, and in loop analysis, you were getting stuck with a current source. So that you get, the procedure is very similar. You're going to get stuck in both areas. Okay, so with nodal analysis, since I've introduced an extra unknown, this IX that didn't used to be there, I have to introduce another equation. So the extra equation that we have to write is going to have to do with this voltage source, which otherwise was not taken into account. What that 5 volts is telling us is that somebody's connected a power source here to force node B to be 5 volts bigger than node D. That's what a voltage source does. It creates a difference in voltage, in this case of 5 volts. So it makes node B 5 volts higher than node D. We would capture that in our extra equation as saying node B is equal to node D plus 5 volts. It's completely up to you what style you like to use, but I recommend some systematic style. Either, as soon as you introduce the extra unknown, by writing the IX there, I think one style is to, as soon as you find the extra unknown, write the extra equation. That way you won't forget it later on. The second style is to just go systematically through all the nodes, and then try to pull in those extra equations at the end. You should be able to catch your mistake if you forget to write that extra equation, because you'll count your equations and unknowns and they won't match. So, but either way, at some point you have to write that extra equation. Here I'd like to put a dot, dot, dot. The main point I wanted to get across was that with nodal analysis, the current source does not give me trouble. The voltage source does give me trouble. And here's how I get out of the trouble. For a voltage source, I introduce a current, and I write down an extra equation. That's the plan. What I'd like to do next is same circuit, but now loop analysis, and show that just the reverse is the case, is true.
You can keep going.
Okay. So in the case of, it just makes me nervous.
I don't have
That's
to
all
do
right.
it anymore.
No, that's all right. No, go ahead. We can also. Would it be better to put the camera in the middle, like here?
It's not so much the angle, it's just I'm concerned about it being so small.
Oh, I see. Okay.
But this is just a trial run. So.
Okay, we'll get better. Alright, so in loop analysis, we have just the reverse. In loop analysis, we're writing the sum of the voltages around the loop equals 0, in which case the voltage sources will be easy, and the current sources will give us trouble.